Welcome everybody. You guys noticed correctly with my videos with all Hackerrank problems that I didn't have the occupations problem in there. And because of that, I'm going to film now the last one remaining. So the text is pivot the occupation column in occupations so that each name is sorted alphabetically and displayed underneath its corresponding occupation. The output column headers should be doctor, professor, singer, and actor, respectively. Print null when there are no more names corresponding to an occupation. Okay, so we have a very simple table structure here. We just have two columns, the column name, which is a string column, and the occupation is a string column. And we have names, which is just a one-word name, the first name, Samantha, Julia, and so on. And we have the occupation, doctor, actor, singer, professor. And now the standard table looks like this. Column name, column occupation, and it's unordered, just one after the other. And the table that we want now is going to be like this. Every column should be one profession. So the first column is doctor, the second is professor, then singer, and then actor. So Jenny, Samantha, they are both doctors. Ashley, Christine, they are professors, and so on. And now you have to think, okay, what do we want to do with this table? This table has a lot of lines, a lot of rows, and we want to make them wider. And whenever you want to do something wider, you can do that with joining. With joining tables on other tables, you can create more columns. This is a good rule of thumb. If you want to make the table wider, you can join. If you want to add more columns, if you want to add more rows, you make union. So you have the same columns and you want to make it longer, then you use the union command. But in this one, we can use the join command, so then we can make the table wider and we can actually create more columns. Because we make from name occupation column, which are two columns, we make 4 columns. One for doctor, professor, singer, and actor. Okay, so now for the understanding, let's select first everything from occupations. And let's just look at the table. Okay, so now we have here the table as the same as our sample, name, occupation, and we have the names and the occupation. Okay, now maybe we order this by occupation. Let's run this. Okay, now we have the actor on top, and then comes doctor, professor, and singer. Okay. So the problem here is that we do have the names ordered here, but they are all in one column and we want to have them on several columns. So my solution attempt here is going to be, I'm going to create actually 4 tables, and one table is going to be for each profession. So the first table that I'm going to create, select name from occupations. This is the first table, and I'm going to create a doctor table. So I say where occupation like, then I say doctor. Okay, so now we have 3 names, Julia, Priya, Amina, which are all doctors. And we have our first CTE, so our temporary table here. And we call this with doctor. We also call this table doctor. And now we say with doctor as this such. So now we have one table that we can use later where we filter the doctors. And now we make another table. For that we use a comma and we say professor. And for professor, we want to make another table here. So we basically use the same syntax and we just change doctor to professor. This is our second table, professor table. Now we want to get the third one for the singer. Singer as, and I get this query again. And then of course I have to change the where filter to singer. And we want to get a last table for the last profession. And this is going to be the profession actor. And we're also going to change this to actor. And now somehow we want to get all of them out. So we want to select all names. I'm going to write here all names from our tables. So how do we do that? Well, we need to join them later. So we need something to join them on. Currently we only have name here in this table, in the 4 tables, and the name column is always going to be with different names. We cannot join the names from actors to the names from singer, so that doesn't work. But what we can do is we can create a number, like a row number for all the names, and then later we can join the tables on this row number. So we create a row number that is basically just numerating all the lines. The first line gets a 1, the second line a 2, and so on. And we say order by, and we want to order by name because it's a saying here, the output column headers should be Dr. Professor Singer and so on. And then each name is sorted alphabetically. So that is important. And that's why we also sort the row number alphabetically so that we can use it later in our join. And it's going to give us already the right names alphabetically. So this is what we are going to use here, row number and order by name. And we're going to use the same column basically in the second table. And the same column also in the third table. And in the last one as well. And now we have a column rn, which is the row number, where we can actually join our tables. So let's select first the professor, p.name from, what is the professor? The professor is here from professor table. We call this p. So now we should get out all the professor names. Yes, here are all the names with professor. And now we want to join the first column, and we want to do a left join because the professor actually has the most number of rows, and all the other professions, they have less number of rows, and we want to display a null value whenever they don't have names anymore. And this is exactly what we can reach with the left join. So left join let us keep all the rows in the professor, and whenever there's not a match of row number in another table, then it creates a null value, which is exactly what we want. So we left join the doctor table, Dr. D, on d.rn, that's the row number that we created so that we can join them, equals p.rn. Let's get this one out here, d.name. Okay, so now we have the doctor column before, and we have null values when there are no more doctors in this line. So this is exactly what we want. And now we get the next one, which is the actor table, a.name. And what was the last one? No, actually the third one is the singer, and the last one is the actor name. And we can join them again. So we can use the same join, and we have to use it one more time. The second left join is going to be with singer, and we write s.singer. That's why we write s here, and then we can also use s.name later to reference this table. We write it on s.rn equals p.rn. And then we're going to lastly join the actor on a.rn equals p.rn. And let's run this code. And we have the solution. Now what you might notice if you really paid attention, or if you were a bit more experienced, is that I purposely joined asked for first from the professor table here, because I knew beforehand that the professor has the most number of profession, the most number of lines. And if I would not have chosen the professor here in the first one, then this actually would not have worked, this code, because if I choose the doctor and he just has 3 names, then I can only maximum join 3 other rows onto it, because I join over the row number. So this solution has a flaw in a way that it is not flexible. I have to manually know that which table has the most number of lines, and then I have to use it as a from in this from clause. So this is not an ideal solution. An ideal solution would be to use something that is flexible on the number of professions that are standing in each column. And that way you don't have to pay attention manually to what table you have to join first. But this is the solution that I came up with now. And if you find a much more flexible solution, then I would also, of course, be happy to hear from it, and you can write it in the description. So thank you very much for watching, and see you in the next video.